Welcome to this video on the topic of index laws. In this video, we're going to review some of the index laws that we may have used in the past, as well as preview some index laws that we might be unfamiliar with at this point in time. After which, we're going to use these index laws to simplify a few algebraic statements. Now, index laws are simply shortcuts that we use to modify the appearance of algebraic statements. In most cases, we do it to make the algebraic statement easier to understand or work with. Of which we have a number of different index laws that we can employ. Now, the simplest ones are multiplication and division. So these are some intuitive laws that you would have done multiple times when you were doing simple Year 7 and Year 8 algebra. Moving down, we have unintuitive stuff like the zero power rule, in that if you have a to the power of 0, it's going to be 1, unless of course your value of a is 0, in which case it doesn't work. Going down, we have stuff that we probably forgot. So I've got brackets that have been raised to a power, how we deal with those. We have situations where we've got factors inside a bracket raised to a power. We have quotients raised to a power. And then we have some unfamiliar territory where we've got negative powers and fractional powers. Now that we've had a look at some of these index laws, let's have a look at simplifying a few algebraic statements. Now in example A here we have k squared times k cubed. What I'm going to do to be able to enter this problem is I'm going to bring up my index laws as a reference. Alright, now looking at A, this might seem quite simple in that we know the answer is going to be k to the 5, but let's have a look at our index laws to understand why it's going to be that way. In index law 1, we have a to the m times a to the n, and it tells us that that's going to result in a to the power of m plus n. So in this case, we add the two powers together. So this is pretty intuitive in that we've been doing this simply in our head since Year 7 and Year 8. We simply know that they just add together. So the result is k to the power of 5. We do this using rule 1. Alright, B, we have p to the 6 divided by p. Now there's a few ways in which we can tackle this problem. The first way in which we can do it is we can look at our rule 2, division. So this tells us that if we're dividing two factors, differing powers, same bases, we simply negate the second base or the second power from the first power. In which case we're going to have a implied value of 1 in front of that p because it's not shown. So that's one way we can look at it. The second way we can look at it, which is my favorite way, is to use rule 7, which is the negative power. So you've got a to the negative n is equal to 1 over a to the n. Or another way to think about it is that you've got a to the n under a 1 and you get the left. So we're going to go from right to left here. So to break this up, we're going to go p to the 6 multiplied by 1 over p to the 1. Now using rule 7, I'm going to change it to this form seen on the second line here. And then using rule 1, we're going to add them together. 6 plus negative 1. Thus yielding a value of p to the power of 5. So a little bit overcomplicated, but it explains why it works. Going down to C, we have 3c cubed times 3c to the 4. Now there's a few ways in which we can represent this. The simplest way is you're going to multiply the coefficients together. So 3 and 3 in our besties. And then we're going to go c to the 3, c to the 4. Using index rule 1, we're going to get 3 times 3 is 9. And then the c's are going to be 3 plus 4. So index rule 1 again. This is going to yield a result of 9c to the 7. So nice and simple. Now we start getting into the fun. We have example D. 14x to the 5 y to the 2 divided by 2x to the 2 y. Now the way in which we're going to tackle this is, firstly we need to factorize this number. So we need to look for common factors. Now simply looking at this, I know the factors of 14 are 2 and 7. So I'll go 2, 7. Then we have x to the 5 y to the 2, and that's all over 2 to the x squared y. Now, because we have common factors in here, we see there's a 2 and a 2, so we're going to kill them. And then, to continue working on this problem, we're going to remove the whole fraction altogether using index law 7. So we're going to get 7 at the front here, x to the 5, y to the 2, and here's where we promote the denominator to the numerator. We're going to go x to the negative 2, y to the negative 1. Applied 1 there. This was using index law 7. Now using index law 1, we're going to go 7x to the 5 plus minus 2, y 1 plus minus 1. So there's a 1. No, that's not a 1. That's a 2 still. Very good. Alright, so we're going to go 7x to the 5 plus minus 2 is 3. Then y is going to be an implied 1. So the answer to this is going to be 7x cubed y1, or we can just get rid of the 1 and say 7x cubed y. Nice and easy. Alright, moving on. Now we're dealing with some really fun stuff. So what we've got are brackets that have been raised to a power. There's powers inside and outside. So what we're going to have a look at is using our index laws, which ones will we use? So looking over here, we have brackets. So brackets over here. Brackets over here. So index law 4. So when we have a power inside and a power outside, we simply multiply the inside and outside together. So what this is going to do is we're going to get 2 to the power of 3 and n to the power of 4 times 3. Now, it might be nice and simple to think of it as 2 to the 3 like that, but we need to remember there's an implied 1 in the 2 there. So what we're effectively doing is going 1 times 3. Simplifying this out, it becomes 2 to the 3, and then it becomes n to the power of 4 times 3, which is going to be 12, I believe. And then if we want to evaluate 2 to the 3, we can go 8, nice and easy. This was using index law 4. Continuing on the fun, we have a similar problem. We have 3a squared b7, or to the power of 3. So we've got multiple factors inside the brackets that's been raised to a power. We're going to do the exact same of what we did to above to solve f. So doing this, we're going to go 3 to the power of 3, a to the power of 2 times 3, and then b to the 7 multiplied by our friend 3. Evaluating this, we have 3 to the 3 for now. Then we're going to have a to the power of 6, b to the power of 21. And if we want to evaluate the constant, we're going to go 3 times 3 times 3. That's going to be 27. A6, B21. Again, done using number 4. Going down to G, the fun intensifies. We have a quotient inside a bracket, so we're dealing with index law 6 here. Now, index law 6 tells us that if we have a quotient inside the bracket, then the power itself is going to be pushed on both the numerator and the denominator. So a over b, all to the power of m, is a to the m divided by b to the m. So carrying this out, we're going to go 2 to the x 3, and we'll go 4 like this. And then we're going to go y to the 4, also with a 4 outside. So this is index law 6. Then evaluating this, we're pretty much dealing with a case of index law 5 now. So we're going to go 2 to the 4, x to the 3 times 4, all over y to the 4. Solving. We're going to get 2 to the power of 4, so that's 16, I believe. X to the 12, all over y to the power of 16. Nice and simple. And then we have our final problem. We have negative 4 to the power of 3. So what looks like an index law problem is actually just a simple constant problem. Now the way in which we can solve this is we can think of it as -4 times -4 times -4. That's going to be -16 times +16 times -4, and then that's going to yield a value of double that, it's 32, so 64, and there's a minus. So 3 negatives gives us a negative overall. So that's how we solve the final one. So in review, what we had to look at was index laws, and then we use these index laws to solve or to simplify a number of algebraic statements. Now, the reality with using index laws is that the only way in which you're going to remember all of these is through thorough practice. So please ensure that you're practicing enough questions to memorize all of these index laws. It is no good to simply have to look at a cheat sheet during the middle of a test because you'll lose time. Similarly, you won't be able to pick up on some nuanced questions unless you have these index laws memorized.